Problems on momentum. Problem 1. A body of mass 25 kg has a momentum of 125 kg meter per second. Calculate the velocity of the body. We know P is equal to m into V. So now we know what is P, 125, and mass is 25 and velocity is unknown. So V is equal to 125 divided by 25. So 25 ones, 25 fives, which is 5 meter per second. Problem 2. A man throws a ball weighing 500 grams vertically upwards with a speed of 10 meter per second. What will be its initial momentum? So its initial momentum P is equal to m into V, and m is 500 grams. So wherein we need to convert the grams into kg. So we know that 1000 grams is 1 kg, and hence 1 gram is 1 by 1000 kg. So 500 grams become 500 into 1 by 1000, and V is 10 meter per second, so 10. So 500 ones, 500 twos, and 2 fives, which becomes 5 kg meter per second. We'll go to the next part of the question. What will be its momentum at the highest point of its height? The ball is thrown vertically upwards with a velocity of 10 meter per second. And when it reaches the top, the velocity will be 0. Hence, at the highest point of its flight, the momentum will be m into V, and mass is the same, 500 grams, which is nothing but 500 by 1000 kg, into V is 0 meter per second. Since at high point the velocity is 0, and that is the reason it starts falling down. Hence P is equal to 0 kg meter per second. Problem 3. What is the change in momentum of a car weighing 1500 kg when its speed increases from 36 km per hour to 72 km per hour uniformly? So let us see the first part of the problem. So the given parameters are mass of the car, which is 1500 kg, and speed of the car, 36 km per hour. For momentum, we need to have velocity in terms of meters per second. So we'll convert this into meter per second. So this becomes 36 into 5 by 18 meter per second, since 1 kilometer per hour is equal to 5 by 18 meter per second. So now on cancellation, we will get 18 ones, 18 twos. So this becomes 10 meter per second. So the momentum P is equal to m into V. So here m is 1500 and V is 10. So this becomes 15,000 kg meter per second. And in the second bit, we see m is equal to 1500 kg and V is 72 km per hour, which will be 72 into 5 by 18 meter per second, which is 18 ones and 18 fours. So 20 meter per second. Hence the P is equal to, in this case the momentum is M into V, which is 1500 into 20, which is 30,000 kg meter per second. Now if we call this the first bit momentum as P1, second bit momentum as P2, we get the change in momentum as P2 minus P1, which is 30,000 minus 15,000, which is 15,000 kg meter per second. Let us see problem 4. What is the momentum in kg meter per second of a 10 kg car traveling at 1. 5 meter per second, 2. 20 centimeter per second, 3. 36 kilometer per hour. Let us take 1. P is equal to M into V. Here mass is 10 kg and V is 5 meter per second. Hence P is equal to 10 into 5, which is 50 kg meter per second. Take the second one, in which V is equal to 20 centimeter per second, which is converted as meter per second, which will become 20 into 1 by 100 meter per second. Since 100 centimeter is 1 meter, therefore 1 centimeter is 1 by 100 meter. Having known the V in terms of meter per second, we know P is M into V, and M is the same as 10 kg and V is 20 into 1 by 100. So 10 tens and 10 twos. This becomes 2 kg meter per second. Taking the third part of the problem, here V is equal to 36 kilometer per hour. So we need to convert the kilometer per hour into meter per second, which means 5 by 18 meter per second, 18 ones, 18 twos, which is 10 meter per second. We did this conversion because 1 kilometer per hour is equal to 5 by 18 meter per second. So now to find out the momentum, P is equal to M into V. M is 10 kg and V is 10 meter per second, 100 kg meter per second. So now we know from this, we understand one thing from this problem. The mass is same, but the speeds are different. And the momentum is the least when the velocity or the speed is the least. Momentum is maximum when velocity or speed is maximum. Problem 5. A car is moving on a level road. If the driver turns off the engine of the car speed decreases gradually, which we see always in our regular daily life, and ultimately stops. A student says that two forces act on the car which bring the car to a stop. What are these forces? So the forces that act on the car when it reduces the speed but ultimately stops, instead of going in the continuous motion, it comes to a stop because there is an opposite force that is acting on the car. Those forces are A. Force of friction, and B. Air friction. And which force contributes more to the slowdown and stopping of the car? Force of friction contributes maximum to slow down and stop the car.